Now, if the examination, your examination is to be taken on online method, online mechanism, then you may determine the weight of security X by applying the common formula which is discussed in your past class, and this is the common formula for determination of weight: sigma y square minus cob xy divided by sigma x square plus sigma y square minus 2 cob xy, and according to this formula the weight of security X comes to 83%. So this is the common formula that can be applied for determination of the weight of security X and security Y, whatever the value of the correlation coefficient is given in the question. But if the examination is taken on offline basis through paperwork, then you will not be permitted to solve the question by applying this shortcut formula. This shortcut formula is to be used only if the examination is taken on online process. It will minimize your time also, and by applying this formula you can verify the answer that you have solved the earlier. Now the next question is that was appeared in year 2016 in 6b, question number 6b. Here also expected return of security X and security Y are given. It is 10% and 15%. Variance associated with security X is 4% and security Y is 9%. So risk relating to security X is root over of variance, that means sigma X equal to 2%, sigma Y equal to 3%. In accordance with the Markovitch diversification principle, we have to examine whether a risk averse investors will have any diversification benefit in forming a portfolio of the above two securities in the following cases of covariance between their return. If you recommend a portfolio formulation, then also determine the minimum variance portfolio combination and the risk return profile of such combination. That means first we have to test whether there is any diversification benefit or not by constructing the portfolio. If there is diversification benefit, then we have to calculate the weight, and according to this weight we have to calculate the expected return and risk of the portfolio. Now in first question, covariance between security X and security Y was given as 0. Now if the covariance of security X and security Y is 0, then correlation coefficient of security X and security Y, which is calculated by applying formula cob xy divided by sigma x into sigma y, comes to 0. What does it mean? Correlation coefficient between security X and security Y is equal to 0 implies that their security are independent of each other. That means changes in the return of security X does not have any impact on the return of security Y. So here the security X and security Y are independent of each other, and we know that whenever Rxy equal to 0, then investor will get diversification benefit by constructing portfolio with security X and security Y, but here forgetting the maximum diversification benefit, the weight relating to security X will be sigma y square divided by sigma x square plus sigma y square, and weight of security Y will be sigma x square divided by sigma x square plus sigma y square. Now when Rxy is equal to 0, what will be the optimum weight? We have discussed it in our earlier class, and in that class we have measured the formula that is to be used to minimize the risk of the portfolio when Rxy equal to 0. And the formula is that when Rxy equal to 0, the optimum weight that is to be assigned for security x is sigma y square divided by sigma x square plus sigma y square, and weight of security y will be sigma x square divided by sigma x square plus sigma y square. Since the value of sigma y square, sigma x square are given in the question, that means variance of security x and security y are given in the question. By putting this value, we can calculate the weight of security x, which comes to 9 by 13, and weight of security y comes to 4 by 13. I repeat again, this formula has been calculated in our earlier class. When Rxy equal to 0, we have to use the formula Wx equal to sigma y square divided by sigma x square plus sigma y square and sigma y square, and Wy equal to sigma x square divided by sigma x square plus sigma y square. Where from this formula is generated? This formula is generated by applying the technique of differentiation by putting the value of Rxy equal to 0 in the variance function of the portfolio, and this formula was calculated in our last classes, and by taking knowledge from that classes, we can use this formula for determination of weight of security x and security y, where Rxy equal to 0. Now, by putting this formula, we calculate the weight of Wx and Wy first, and here weight of security x comes to 9 by 13 and weight of security y comes to 4 by 13. Now, by putting this weight, we have to calculate the expected return of the portfolio. It comes to 11.53%. Here Wx is 9 by 13, expected return of security x are given in the question, it is 10%. Weight of security y is 4 by 13, expected return of security y is 15%. So the expected return of the portfolio comes to 11.53%. Now the risk of the portfolio is to be calculated by applying the formula sigma p equal to root over Wx into sigma x square plus Wy into sigma y square plus 2 into Wx into sigma x into Wy into sigma y into Rxy. Now by putting the value of Wx, Wy, sigma x, sigma y and Rxy, here Rxy equal to 0, so this factor will be 0. By putting all these values, we have the portfolio risk equal to 1.67%. Now where cov xy equal to 5, that means where covariance between security x and security y is equal to 5, then correlation coefficient of security x and security y comes to Rxy equal to cov xy divided by sigma x into sigma y, it comes to 0.83. Since here the correlation coefficient between security x and security y varies from 0 to 1, here the securities are positively correlated but not perfectly positively correlated. In that case, we have to test the threshold condition. Now the threshold condition is that Rxy equal to sigma x, Rxy less than sigma x divided by sigma y. That means here the threshold condition is Rxy less than lower sigma by higher sigma. Now in the left hand side we have Rxy, which is 0.83. In the right hand side we have lower sigma by higher sigma, it is 2 by 3, so it is 0.67. So here left hand side, that means Rxy is not less than equal to lower sigma by higher sigma. Since the threshold condition is not satisfied here threshold condition is not satisfied. Since threshold condition is not satisfied, here the investors does not have any diversification benefit by constructing the portfolio of security x and security y. Here the risk averse investors will invest all their money, invest all their fund in lowest risky security, that means in security x with expected return of 10% and associated risk of 2%.